So, chapter 15, this is going to be section 2. We're going to be solving quadratic equations by factoring. First off, a quadratic equation, we're going to have this ax squared plus bx plus c, and it's going to be equal to 0. So, remember, an equation has to have a left side and a right side. So, a quadratic equation, notice how there's what's called, it's also called a second degree equation, because notice how the highest degree term is 2. So, this is a degree 2 equation. Notice how, remember, the x has an exponent of 1, that's degree 1, which we called linear, and then the c is a number which represents just a constant. So a second degree equation, what that means to us is it can have up to two possible solutions. So a linear equation just had one solution possible, but a secondary degree equation can have up to two solutions. So the quadratic term is the term with the power of 2. So the ax squared is what's called the quadratic term. The linear term just has the x. So bx is called the linear term. And then the constant is the number. So the c is going to be our constant. So we have that kind of going on with us. So one of the things we're going to use as a strategy is what's called the multiplication property of 0. So this is an interesting property. It's not used a lot in daily life, but in algebra, it's actually an interesting little thing that allows us to solve some of the easier equations. So the multiplication property of 0 says this: if one of the factors is equal to 0, then the product is also 0. So if I have the statement A times B is equal to 0, where A represents a factor and B represents a factor, because remember factors are connected by multiplication, this can only equal 0 if A is equal to 0 and if B is equal to 0, or I should say, or B equals 0. So this is only going to be true if A is equal to 0 or B is equal to 0. So if I look at this equation, notice how it is a quadratic equation because it's a second degree equation. So a second degree equation can have up to two solutions. Now the strategy we're going to invoke is what's called factoring. So what I want to do is factor this left-hand side. And what we pick up on this one is it has what's called a greatest common factor. So notice that the two terms are x squared and negative 10x. Again, remember how we also could do this in a box. So I have this, the two terms are x squared and negative 10x. And what I'm looking at are, do these two terms have anything in common? Well, notice how they both have an x in common. So I can actually factor the x out. And then up here, what times x is x squared? That would be an x. And what times x is negative 10x? I would need a negative 10. So these would represent the two factors. So notice over here, there is a common factor of x, which you would pull out. And then in parentheses, you write the remaining expression. So if I take an x out, that leaves me an x. If I take an x out of this term, that's going to leave me my minus 10. So this is now going to equal 0. So notice how this x and x minus 10 are my factors, so they're going to be connected by multiplication. Now, based on the multiplication property of 0, if one of those factors is equal to 0, then the whole thing is equal to 0. So notice how we are equal to 0 over here. So if the right-hand side is 0, for this to be true, the left side's got to be 0. And the only way the left side can turn into 0 is if one of these factors is equal to 0. So what our strategy is then is we just set each one of these factors equal to 0. So we set x equal to 0, or this x minus 10 can equal 0. So one of those factors has got to equal 0. So notice how this is already solved for x. So if x equals 0, then this whole thing is going to turn into 0. So notice that if I put a 0 in, 0 squared minus 10 times 0, does that indeed give me 0? Well, 0 minus 0, does that give me 0? Yeah, 0 does equal 0. So that is a solution because the left side does equal the right side. Now, the other thing is this x minus 10 is equal to 0. What makes this factor turn into 0? Well, if I add 10 to both sides, I would get x equals 10. So notice that if I put a 10 in, 10 squared minus 10 times 10, does that equal 0? Well, 10 squared is 100. minus, well, 10 times 10 is 100. Does 100 minus 100 give me 0? Yeah, that's a true statement. So it checks out. So my two solutions are then x equals 0 or x equals 10. That would be my solution. As a solution set, we can write this as 0 and 10 would be my two solutions. So I can also use a set notation. So your answer could be expressed in this form. Those are your solutions. Or sometimes the book wants a solution set, so we only put the solutions inside what's called the set notation, the parentheses, the braces.